Hello guys, welcome to another video. Today we are going to solve a question named cyclically rotate an array by key. This question can come in variations that can be cyclically rotate an array by 1 or any other means. But we are going to solve cyclically rotate an array by k. If the question comes for 1, there is a simple approach I will tell you. You can simply use this approach also, it will work. So the question says that we are given an array. For example, this is an array 1, 7, 6, 8 and 10, and it will be said that cyclically rotate this array by 1, then this array should become like this: 10, 1, 7, 6, 8. And if it is given that cyclically rotate this array by 2, then this array should become like this: 8, 10, 1, 7, 6. You get the point. So basically, this one has a simple approach and this has the same approach as cyclically rotate an array by k. The brute force approach is simple. Simply take this array and copy this array to another array. For example, you take this array and create a new array of the same size, and after 1 means you have to cyclically rotate this array by 1 na? So you just place all the values after one place. For example, 0, 1, 2, 3, 4. You start placing 0 at 1th position. 1, 7, 6, 8, and you place the last element to the first element. You can also basically do this solution for another question like for 2, 3, 4. This is a brute force approach, and the space complexity of this question should be big of n, and the time complexity is also big of n. But we are going to solve this question in big of n time without using any extra space, that is big of 1. How? Let's see. For example, let's take k to be 7 or anything. What happens now? The size of array is n equal to 1, 2, 3, 4, 5, 5, and k is bigger than 5, meaning you have to first rotate this full array 5 times, and after that you have to rotate this 2 more times, right? Meaning after 5 rotations this will become the same array. So why not just take the remainder, meaning do a modulus function here by n and take the remaining elements, that is 2. This is how many times we have to rotate the array, right? You can check this out. 7 modulus 5 is 2, and after 1, 2, 3, 4, 5, 6, 7, you have to rotate this array by 7. So after complete rotation of 5 elements, you will only get 2 rotations left. So k can be anything. You just have to do a modulus to find out the real value, that how many times you have to rotate this array. Okay, now we know that we have to rotate this array by actually 2. So what we can do here for the optimal approach is reverse this whole array. Just listen to me. Reverse this whole array. After reversing this whole array, what we will get here is 10, 8, 6, 7 and 1. Okay. After reversing the array, you have to reverse it 2 more times. but for specific number of elements. What I mean by specific number of elements is you have to rotate elements till 2, meaning this is 0, 1, 2, 3, 4, meaning you have to rotate the first 2 elements and after that rotate the remaining elements, meaning you have to rotate these 2 elements. The number is 2 here because if it is 3 you have to rotate by 3, if it is 4 you have to rotate 4 elements, remember that. But it is 2 now, so we will rotate these 2 elements. This will become 8, 10, 6, 7 and 1. After you have rotated these 2 elements, you have to rotate the remaining elements, meaning these elements. So it will become 8, 10, 1, 7, 6. And you can check after rotating 2 times, this array will come. If you see, 10 will come here after 2 rotations, 8 will come here, that is here, 8 is here, 10 is here. After 2 rotations, 1 will come here, 1 is here, 7 will come here, 7 is here, and 6 will come here, 6 is here. So you have to do total 3 rotations. Rotation number 1, where you have to rotate the full array. Second rotation, up, meaning the remaining rotation numbers. You will get it from k percentile n, that is k modulus n. The number of rotations you will get it from here. You have to rotate it, rotate the first rotation elements and after that the remaining elements. Now let's see the code. So here is the question. You have to rotate the array by k times. So like I said, you have to rotate the you have to reverse the array 3 times for doing this question in big of n time and without using any extra space. How can we do that? Let's see. So you have given the array, you have given the number of rotations. First of all, we have to do here is we need to know how many elements we need to rotate in the second rotation. So it will be like rotation, that is k percentile n. This will give us the number of rotations that we need to do after the full rotations are complete, and it will also give us the number of elements that we need to rotate in the second reversing elements. So after you have got the rotation number, you have to rotate the elements the array 3 times. So we will create a rotation function which will take nums, the starting point that is 0 and the ending element that is n minus 1. This is the first rotation that is reverse the whole array, and we will name it reverse. After this is complete, the second reversal process starts, and that is reversing the array up till rotation elements, meaning how many rotations we have to do. We have to only rotate that many elements. After that we have to reverse remaining element, so it will be like nums, it should be rotation minus 1 because we have to rotate only the starting rotation means 2 elements or 3 elements, but here it will be an index, so we have to give minus 1 because index starts from 0. So it will, the next rotation of remaining elements will start from the index of rotation, that is 2 or 3, whatever the value of rotation here is, and it will come till n minus 1. This will reverse the remaining elements. So this is the only process. Now we need to create this reverse functions, so we will create it here. If you don't know how to reverse an array, you can watch my previous video where I have explained how you can reverse an array. You can find the link above or in the description. Now we will be having nums. We will be having a starting point and we will be having a ending point. So the process is simple. You have to just swap the values. So we will be swapping the values here, while, and the condition is I should be less than equal to j. We will be checking I should be less than equal to j, and we will be swapping till that point. And what we need to do here is we need to swap out the ith position to the jth position. That's it. We will take ith value into the temp. We will replace the ith value with jth value, and we will replace this jth value with the temporary value that we have hold. That's it. This will swap out the values. After that, we have to increase the index of I and we have to decrease the index of j. This is the process of reversing an array. You can watch out the explanation in my previous videos. You can find the link in the description. This is the only function that you need to rotate an array by k steps. Let's see. Hopefully this should work. Okay. Okay, we have not defined n. Yeah, right. We need to find n first, and that should be nums dot length. Hopefully this should work now. Yeah, you can see we have a working solution. We can submit it here and see. Yes, success, and we have passed with flying colors. So guys, let's meet in the next video where we will be solving another question like this.